of functions, this is our warm-up. So I am going to go through the first one with you just to make sure that we know how to do this, and then I'd like you to try the other two on your own. So for the first one, remember when we're finding f plus h of 1, that's saying when my input is 1 in f and when my input is 1 in h, what is my answer when I put them together? So the first thing I want to do is I'm going to want to find what f of 1 is and then what h of 1 is. So I find that out. I get 7 times 1 minus 2 plus 9 times 1. So 7 minus 2 plus 9, 5 plus 9, and I get 14. So go ahead and hit pause, and I'd like you to try the next two on your own. Okay, so we are going to go to the next one. So we're going to find g minus h of negative 2. Again, I want to find g of negative 2 minus at h of negative 2. So I am going to plug in all the different things that I know. So I know that everywhere I see an x, I'm going to replace it in both functions with a negative 2. The other thing that I'm going to do is I'm going to be careful to leave my minus sign right here because we're going to have to think about that later on, especially when we're dealing with variables. All right, so then I do the computations. Negative 2 squared is a positive 4. Negative 2 times negative 2 is a positive 4. And then 1 minus negative 18, which ends up being, once I distribute this, so remember this right here becomes a plus, and I get 9 plus 18, which is, so g minus h of negative 2 is equal to 27. So these questions, again, are asking, when my input is negative 2 in both functions, what is my answer when I subtract them? All right, so now let's do the last one. So we're going to do g plus f of 3q. Again, these are really good examples of progressing level questions. So we're going to find g of 3q, and then we're going to add that answer to f of 3q. So first I need to find g of 3q, and then f of 3q. So I get 9q squared. Make sure that when we are squaring something, a monomial like this, we square both the coefficient and the variable. I distributed negative 2 times 3, which is negative 6, plus 1. We end up with 21q minus plus 1. Okay, so then we end up with 9q squared minus 6q plus 1 plus 21q minus 2, which means I need to combine my like terms, and go ahead and put them in the same color so that you can see them. And then I get g plus f of 3q is equal to 9q squared plus 15q minus 1. Again, if you have any questions, please feel free to ask me those questions. Understanding this is going to help us later on. So today, I am going to be using these two functions over and over, so make sure you put these functions in here. So again, what this is saying, this question is saying, given these two functions, so if f of x is 4x plus 3 and g of x is negative x squared minus 3x, I want to know what is my new function when I subtract them. So the first thing I'm going to do is remember that I'm just going to substitute. I know what f of x is. F of x is 4x plus 3. I know what g of x is. G of x is negative x squared minus 3x. So I can substitute those in. But if that's something that's difficult for me, I know that I can just replace all my x's. So my new input is x with x. So then we end up with 4x plus 3. So notice f of x is equal to this, and that's exactly what I have here. G of x is equal to this, and that's exactly what I have here. It works when I just replace it with the strategy that we've been using with numbers. So it works either way. I just want to show you that you are just substituting. Okay, so once we do that, we need to distribute the negative 1. So there's a 1 right here, and I need to multiply all of that by this, and I need to multiply that by this. So I end up with 4x plus 3 plus x squared plus 3x. Then you are going to combine like terms. That's okay. Okay, so then you combine like terms, and you're going to get that when I subtract these two functions, my new function, f minus g of x, is x squared plus 7x plus 3. So we're going to do that with two more operations. So that's subtraction. Now we're going to do it with multiplication and division. All right, so to do that, again, we're going to substitute g of x times f of x. And we end up with, there's my g of x, there's my f of x. I've got it right there. I've got the colors matched. I also did the step before where I just replaced the x's with x's. Now, we have a binomial times a binomial, which means we need to put it in here. I typically do it this way, so negative x squared minus 3x, let's see, 4x plus 3. If you do it the other way, like you have the 4x plus 3 over here, as long as you keep your binomials on the same side, you're fine. We end up with negative 4x cubed, negative 3x. Okay, and then we get 4x times negative 3x, which is negative 12x squared, and negative 3x times 3 is a negative 9x. Okay, remember we're always going to combine like terms. These ones are the same. All right, so we end up with, so when you add everything together, you get negative 4x cubed minus 12x squared minus 3x squared minus 9x, and we combine our like terms and we end up with negative 4x cubed minus 15x squared minus 9. All right, so now we're going to do the same thing with division. So again, I'm just going to substitute. I know what f of x is. It's this right here. It's 4x plus 3. I know what g of x is. It's negative x squared minus 3x. And I'm going to plug that all in. So I end up with 4x plus 3, negative x squared minus 3x. If I factor out an x over here, I still can't simplify it any further. So I am totally done. That is my final answer. But I do need to be checking for that. Okay. Now, I'm going to ask you to do the same thing with those functions, but with a numerical value. So I've got f plus g of 2. So we already found earlier, we found that we needed to do f of 2 minus g of 2. So we can do this strategy where we replace it, we get numbers, and we end up with 21. But we already found f minus g of x. We found that was the first one we found, which was x squared plus 7x plus 3. Well, look at this. I can replace all of that with 2 and just do that, and I still end up with the same answer. So one of the strategies that I like to teach students is if you see something like this, find it of x first and then just replace it with 2's or replace it with the new input that they're asking for. So we could do the same thing here. So I'm going to find g times f of negative 1, and I can use those same strategies that I've used before, and I'm going to end up with negative 2. Or I've already found it. Now I can just replace that with a negative 1, and I still, oh, my face is in the way. I'll get it out of the way. I still end up with negative 4 times, oops, let's see if I can, there we go. I still get negative 2. So either way works, especially with numerical order, but when we're talking about something with variables, it's much easier to find this one first and then replace it with the variable. So again, it'll work for division. We could do it the way that we've done it before, the way that we started our warm-up, and we end up with negative 5 over 6. Or I've already found f divided by g of x. I'm going to replace those with the 3, and I still get negative 5 over 6. Negative 5 over 6. So that works every time. This is a strategy that I like to use. It helps me practice doing variables, and it makes sure that I can do it. So this is going into meeting level. Now, I would like everyone to hit pause and try to find f minus g of 8x minus h. So go ahead and hit pause. Okay, so you should have done that. Again, we can find this the way that we did it in the warm-up. I'm not going to go through that because that's a lot of extra work. You have to combine like terms, you got to distribute. I've already done all that work with one variable, so I'm going to go ahead and take my f minus g of x. Since I've already done that, I've already taken care of it, I only have to replace these two right here, this one and this one. I don't have to replace 3 different x's. So then I end up with x minus h squared plus 7x minus h plus 3. So remember, right here, this is a binomial. We need to put that in a box. When we put that in a box, we end up with, and we can do that over here. So you need to do this, unless you remember how to do, but we should have x minus h, x minus h, and you're going to end up with x squared, negative hx, negative hx, and then negative positive h squared, because a negative times a negative is a positive. All right, so you're going to end up with x squared minus 2xh or hx. It doesn't matter, but we have two of them. They're right here. These are like terms. They're exactly the same. Plus h squared plus 7x minus 7h plus 3. Notice that I don't have any like terms at all. None. So if I don't have any like terms, I'm totally done. So this trinomial, because we're multiplying by binomials, ended up being a polynomial. So we have 1, 2, 3, 4, 5, 6 terms. Okay, for the rest of the period, you can work on your homework. It is due tomorrow. It is graded on accuracy and completion, and you won't be able to move on to the next assignment till those two things are done. So make sure that you spend the rest of the class working on that. If you have any questions, if you're in 8th period, Mr. Jessen is in there, you can ask him. Otherwise, write down your questions and I will make sure that I answer those tomorrow. So I hope you all have a great day and I will see you later.